Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and today we're going to be looking a little bit deeper at the surface shader that we wrote yesterday and not surface shader, the shader that we played with yesterday, and we're going to convert it into a surface shader and kind of explain how it works along the way. And also explain kind of the difference between surface shaders and regular shaders, quote unquote. So first off, what we were working with was this cool little palette shader, and what it does is it has a texture map that represents the value of where to actually pull this information from in the shade from the second texture. And the second texture contains the color information, and so what we're doing right now is we're just moving the offset on the color information, and so it creates this kind of like lightning effect because the clouds kind of represent these flow fields effectively. It's like what's the best way to explain it? Those surface maps and stuff of the Earth, which have the elevation differentials. Each of those elevations would be colored differently based on this information here, and now we're just sliding that information, so it just shifts through all of the elevations effectively. If you're thinking about this kind of as a height map in this case, So one of the things about this shader is a standard Vertex fragment shader. It's written in CG with of course Unity strappings and stuff. So what to note on this, and actually for this type of shader, it may be appropriate to just be like this, but it doesn't actually take lighting information into account. So like if we increase our lighting in the scene or decrease it, it does not have any effect on this object. And I'm going to put another just like sphere in here so that we can see the effect. So if we go to the directional light again and I pump up the brightness, you can see that the left sphere is being affected by it and the right sphere is not. So sometimes that's desirable and sometimes it's not. We're going to be converting it into a surface shader, which is actually going to give us that lighting information, quote unquote, automatically. So let's take a look at this shader first, kind of go through it, and then we're going to convert it into a surface shader. It's going to be very, very easy. It's actually going to be easier than you think. First of all, there was a couple when I was building this initially, some of it was copy pasta from the internet, and so there's some stuff that I did not actually clean up. One of the ones is texture mix and projector here. We actually aren't using either of these. We can safely delete them, save, and you'll see that if we hit play, the shader will work just fine. So, but there's a couple things that you can't delete and that look like we're not using them anywhere. One of them is the main text st and second text st. These variables represent the offset data. Basically, what they represent is they represent the tiling and offset data for the represent the tiling and offset data for each material. And if you remove them, what happens is we'll get a compile error. And it'll say main text st undeclared identifier. And you're sitting here, it's like, wait, but no one here uses main text st. I don't get it. So why would this even matter? I don't even understand why this variable is here. And the reason it's here actually is because of this right here, transform underscore text. This is a macro. And what a macro is, it replaces this with a specific, it replaces information here, just in line, with other information based on what we pass in here. And you can see where this is defined. I've got the built-in shaders in the project here. By the way, if you need the built-in shaders, just search built-in shaders Unity. And in download archive, you will see you can download the built-in shaders for Mac or Windows. I think it's the exact same download in either case. And from here, we've already got them in the project though, so if you've got the project locally, they're in this built-in shaders folder. And what we want to look at is Unity CG here. So in Unity CG, down 200 lines in, you'll see that we have this transform text name, and what it does is text.xy times name number underscore st, and then plus name number underscore st. And what this basically turns into is these things. So it basically puts the name main text and then concatenates it with st. That's what the little number operation is, I guess. So this just gets replaced by this line, and that's the reason that we need these functions, is because these basically transform text just automatically assumes these variables with the st underscores are there. So we're going to put these back. So that's where those come from. So these represent the actual textures. These represent the offsets. And then additionally, we have vertex information. We have UV information. But that's when you're writing a standard shader in Unity, that stuff is passed in through the vertex input and fragment input sections. So the vertex input, you can basically name these whatever you want, and then these represent what they are in CG. And so vertex here, but it actually means the position, and so there's special stuff that goes on in the background for that. And text chord is the text chord 0. This means the texture UVs. And we could have called it whatever. You'll notice in the fragment input it's still called text chord 0, but it's a UV. And then there's SV position here. I really don't fully understand why there's a difference between SV position and position, but there is. So if someone has an explanation for that one, I'd love to hear it. There's still a lot I don't know about shaders, so bear with me on that. So what's actually happening here is the vertex shader is the portion which is rendering the polygons. It's actually, rather, the vertices of the polygons. And then the fragment shader is what actually renders the pixels, the final pixel colors. And so the vertex input comes in here. It creates a fragment input, which is representative of this struct here. And it sets the position, which this is important because the position is used internally for actually calculating where things are on the screen and everything. So you need to set an output position to have a useful vertex shader in almost any application. There may be certain specialized cases where you won't need this, but and what this does is this is just changing it from the model view projection. So what this means is this is just converting this position from object space into world space, I think. And then I may be wrong on that, so if I am, don't blame me on that. But it's something along those lines. And then the UV here is we're just getting transform.text. This means I care about the offset information. Again, I'm going to point it out here. This means I care about the offset information. We technically don't need to do this, and actually my first version of the script didn't, but I like being able to adjust the tiling and offset on both accounts. So we do this transform.text, and this is just the one for the main texture. So this just represents these values here. It doesn't have anything to do with these. So we don't see the second transform.text until until the fragment shader. So this just gave us, we have a vertex, it's at this position, we want this vertex data. We want this UV data. And so now we get into the fragment shader, and we have the UV data. We've got i.uv here, which represents this variable, which we were passed into here on the vertex shader. And this is, so text 2D, what this does is it gets a value. So normally, let's see, do I have a good example? I'm going to open up another shader here. We're going to do normal diffuse. This is one of the built-in shaders. So text 2D takes two variables. It takes the texture and it takes the UV coordinates. And it can then determine what part of this texture to determine. It uses this to determine what part of the texture to go to and then give you a color out of it. So we go back to our palletized shader. So this is actually just it just takes two parameters. So the first parameter it's taking is second text. So this is saying I want to grab the color from second texture, and the position of the color is this thing here. So what this thing represents, now this is, you'll notice there's another text 2D here. So let's look at that one first. So let's look inside out here. So text 2D takes a main text and it takes the UVs for that texture. So it's determining it's using the point on this to determine, and so we're doing a transform text, second text. We're converting the UV information so that it's now looking up in the second texture. So this is the lookup texture, and grabbing the color based on this value. That's what this ultimately does. Is we use all this information here to grab. So it basically looks in this texture and says, okay, I have a value white of like 255 or something. And then it's like, okay, so go into using that information, go into the second texture and grab after transform texture. So it's using transform text here. So take this information into account and give me a color based on the value. So it goes horizontally. Well, actually goes diagonally is what's technically going. But basically the UV information is pulling diagonally out of this based on the value that it found in this texture. So if the value is low, it will pull from here. If the value is high, it will pull from here. If the value is in the middle, it will pull from here. And ultimately, we now are looking up our palletized texture based on, or we're looking up into our palette based on the value from the main texture UV. So hopefully that makes some sense. So now let's look at making this into a surface shader. So I'm going to convert it by using normal diffuse as a base. So I'm going to duplicate normal diffuse. We're going to bring it into our little folder here. Sorry, this is a little bit long in the tooth on the description stuff, but I want to give you kind of an idea of what's actually going on behind the scenes here. So we're going to call this, what are we calling this? Palletized surface shader. So I'm going to open this up, and I'm just going to put it next to our palletized color here. And what I'm going to do is, first thing I'm going to do is I'm going to name it similarly. You don't have to put it in the push your pixel section. I'm just doing that for the purpose of differentiating it from other things. And palletized color surface is what I'm going to call it. So right now this is just the standard legacy diffuse is what this is. And so now I'm not going to show you how to convert the standard shader into using this color information. You probably could do it. The standard shaders use a lot of macros now. So the thing that's funny about surface shaders are to make it easier to kind of get all the lighting information and cool stuff, and then apply additional stuff to it. Ironically, now the standard shader is much more complex and much more interesting, but there's no surface equivalent for it because it's a lot of operations. So adding stuff on top of it is actually probably going to put you over, especially on like mobile. So these still kind of create the old Lambert shading. All this does is just lighting information. It doesn't do reflection. It doesn't do shininess, that type of thing that's on the new standard shader. So don't expect that. So this surface shader, what it does by default is, so you should look up Lambert shading. I shouldn't say Lambert. It's Lambert. You should look up this shading, and this represents a huge amount of calculations. It takes the lights into account. It takes the angles to the surface. It does all of this cool stuff in the background for us. And in a surface shader, you basically can specify Lambert or Lambert, or you can specify Phong, which is the specular version. This just it determines how the lighting is calculated and stuff. So this stuff is all automatic. And then the surface, all you need to actually do is just specify the color. Actually specify the albedo, but this is we call it a C for because of color, and the alpha. And so you can just specify the color, and it will just do that for the diffuse portion. It'll just do that for the albedo portion, and you'll still get the lighting information on top of it. So what we're going to do is we're going to convert this into this format, and it's going to be very simple. I'm just going to copy all of these and paste them in here just willy-nilly. We're not going to use color. I'm just going to remove color from the equation. We're going to need our second texture, so I'm going to add second text into our properties here. Property stuff is exactly the same between these two. So if I hit save right now, we'll actually get a little compile error. And we'll see well, actually with a couple. So I'm going to get rid of the color. So this would just be a flat texture shader. And we'll get an error, main text ST redefinition at line 64. So this seems really odd, but what actually is happening is this is being defined inside of the Lambert shader. And so we still need the second one here, but this one is actually already exists for us. So we can delete that safely and save. And this should, yay, everything worked. So so now let's actually come in here and change this to have the information that we want. So we're still going to need, I forget if we need something else. There may be a couple more things that we need to do. So what we're going to be doing is basically making this line into our, because in a vertex fragment, the fragment return value is the color. In a surface shader, the color is whatever you assign to albedo. So whatever we calculate for this C is what we want over here. So I'm just going to paste in what we had, and then we'll clean it up. And so if we now save this, actually I don't even think we have to clean anything up. Let's find out what happens. Yeah, we do. Okay. Variable I unable to find. Okay, so this says I.uv here. And so if I undo what we just did, you'll notice that we now have different input variables. So it's in.uv main text is what we want. So we want in.uv main text. We save again. And that should be all we need to do, actually. So let's see if this actually works. So I'm going to duplicate this scene. I'm just going to save scene as. And we're going to put it, I don't know why it just calls it untitled automatically, but we're going to put it inside of here and call it Palletized Surface Shader. Save. And now that we've got that, I'm going to duplicate this. We're going to put it in here. We're going to call it Palletized Color Surface. And I'm going to just keep the old sphere here for comparison, and then we're going to duplicate it and put it over here. And we're going to use I'm going to call this sphere surface and sphere vertex fragment. So on the sphere surface, we're going to change we're going to give it the palletized color surface. And we're going to change this to use Pushy Pixels Palletized Color Surface. And you can see that there was a very slight color change there. So if we hit play now, whoops, what happened there? Did they animate to the center or something? Oh, I'm on the wrong plane. So let's just put this at, what was this one at? Let's put it at 1. Put this one at 1, and then move this to the left and this to the right a little. So if we hit play now, we can see both of our spheres, and actually, which one is the one on the left? Okay, so the one on the left is the vertex fragment, and the one on the right is our new one. So if we adjust our directional light now, you'll see that we now have, you can see that the colors are becoming brighter on this one, and they're not being affected on this one. And if we turn it all the way down, you'll see that the colors become very dark compared to this one. Now we still see some because we've got some ambient light, which we could actually turn off if you wanted to. So let's actually do that just for dramatic effect. So I'm going to go into the lighting. We're going to change, I think it's in here. No. Ambient source. Okay, so ambient source, we'll just do the ambient intensity of 0. And let's, yeah, that's good. And then let's, on the camera, just make it so that it actually just renders a solid color. We'll just render black in the background. So if we hit play now, you can see that we have the surface shader, the right one's very dark. If we change the brightness all the way down, it'll become completely invisible because we have no ambient light. If we bring it up really high, let's make it really dramatic. Okay, it won't let me go more dramatic than that. But yeah, so you get this nice shading based on lighting, And yeah, so that's the surface shader from the other one. Hopefully this will kind of give you more of an idea of how shaders work, and then how to kind of the difference between surface shaders and vertex fragment shaders. I know that there's still lots that makes them difficult and kind of hard to understand at first, but you will get things as you start to play with them. So do play with them, look things up on the internet, search for things. If you don't understand something, do a search, and yeah, work at it, and you'll get this stuff. It's not rocket science. It just looks complex when you first look at it. So I'm gonna go ahead and save the scene. Thank you for watching. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Please support us on patreon.com/cookingwithunity. Really appreciate your support. And you guys have a great one. I'll catch you tomorrow with another Breakfast with Unity.